Hello everyone, welcome to another video. My name is Chirag Dhal and I welcome you all on the behalf of PyNet Labs. In this video, we are going to talk about the transport layer of the OSI model. We'll be discussing about some protocols which are there in transport layer, and we'll also cover about application layer. So let's quickly get started and let's see what do we have to cover in this video. So the very first thing is about transport layer functions. So transport layer perform a couple of functions like segmentation, then the management of connection, which is the end-to-end connectivity, then whether to select the reliable way of data management or data transmission, or whether to go with the unreliable. So that is also again done by the transport layer.
If you enjoyed the content of the video, don't forget to like and share the video and subscribe to our channel.
Then error control is also a part of functions which is performed by the transport layer, which is detecting the errors. Now the types of errors are like single error or can be the burst of errors. The method to check whether there is an error in the packet which is being received from the other end or not is CRC, which stands for cyclic redundancy and checksum. So checksum is the value of the data which is calculated using some, we can say, some sort of mathematical formula. Now this value is again calculated at the receiver's end. So let's say PC A is sending some data to PC B. Then PC A will put that formula on the data, will calculate the value, the checksum value. Now this data will be received by PC B. Now PC B, before accepting that data, will perform the same formula again, will apply the same formula again, will calculate the value, will look for the checksum value. If the value matches, then it accepts the data, otherwise it is going to deny that data. So these are some functions performed by transport layer. When we talk about connection management inside transport layer, we have majorly two protocols there. The transmission control protocol, which is TCP, then the user datagram protocol, which is UDP. Now TCP and UDP differ on some different bases. The first one is connection. So TCP is your connection oriented. It looks forward to building connections. But when we talk about UDP, it is connectionless. Then TCP is reliable and UDP is unreliable. The reason behind we call TCP reliable is that there is retransmission of data in case the data get lost. So let's say the data was traveling from PC A to PC B, but because of some damage, the data got lost in the midway. Now, if TCP is being used, then we can say retransmission of data will be there. The data will be sent again to PCB. But if the same thing happens and UDP is being used, then there is no retransmission of data, even if the data got lost or the receiver never received the data. Then TCP guarantees ordering of message. So as we know that in the transport layer, segmentation occurs. The data is, we can say, divided into smaller parts. Now, when we are using TCP, there is going to be some order of messages. Like if, for example, I am sending hi, good morning, then hi, after that, the next segment, let's say good, then the next segment, let's say morning. This will be received in the same order if TCP is there. But if UDP is there, it can be morning, hi, good. So there is another important, I would say, function which gets into the picture, which is sequencing. So you put a number on the packet. Let's say hi is the number 1, good is the number 2, and morning is the number 3, like that. So that in case it is received in some other order, it can be resequenced or it can be rearranged into something which can make sense. TCP is heavyweight protocol, UDP is lightweight protocol. TCP is bit slow because it has so much of responsibilities. UDP is fast because of less responsibilities. There is the option to control the flow. There is no such option to control flow in UDP. So these are few things on which we can differ TCP and UDP. Then moving ahead, talking about TCP's three-way handshake. Now, before the data is sent to the user, there is a three-way handshake done by TCP, which is like building a connection with a person. So TCP sends SYN messages, which is more, we can understand it in a way like it asks the PC that, hey, do you want to build the connection and receive some data? To which the other PC will reply with some acknowledgement and will send the sync packet again. Then we can simply say that the PCB will reply that, okay, I am good with building the connection with you. This will be acknowledged again by PCA. Once this connection is built, once this three-way handshake is done, the data transmission will take place. So that's how we basically, that is the reason why we call TCP connection oriented. It is looking forward to build connections with the other PCs, right? Then there is this service of DNS, which is domain name system. In the simplest manner, you can simply call it as the phone book of the internet. What is the role of phone book, right? You open the phone book, you look for the name, you look for the number, and you call that, right? DNS is again the same thing. You look for the domain name, you look for the IP, you ping that IP. This is the manner why, like how we use DNS. The domain name system is the naming database in which internet domain names are located and translated into IP addresses. This translation is done with the help of DNS servers. Now you go to your PC, as you can see in this example, you go to your PC, you go and type inside the browser, you type google.com and you receive the web page of Google. You are somehow pinging the Google server, right? But who is going to tell you that what is the IP of that google.com? No one, right? But behind these machines, DNS is the one who is translating your google.com, like the URL which you are typing, the google.com, into the IP, which is the IP address of the Google server. So it is the DNS who do this for you. Great thanks to him. But because let's assume a scenario where you have to type the IP address every time you want to ping Google, or let's say every time you want to visit YouTube, Facebook, Instagram. So all the websites which are there on the internet will have some IP, and you will have to maintain some records to reach out to any website, right? So DNS is something which is translating our domain names. Now we know that, right? Let's move ahead and see what do we have next. So the next thing we have is DHCP, which stands for Dynamic Host Configuration Protocol for IP version 4. Now DHCP is used for assigning the IP addresses with the help of devices or with the help of servers. So it is a network management protocol used to dynamically assign IP addresses to any device or node on a network so they can communicate using an IP. Then DHCP is an application layer protocol which is used to provide subnet mask, router address, and the DNS address. Then DHCP utilizes the port number 67 and 68. 67 is used by the server, 68 is used by the client. So in a communication of DHCP, there is a process of DORA, which is discovery message, offer message, request message, and acknowledgement. So this DORA stands for discover, offer, request, acknowledgement. This is the communication which happens between any client and the DHCP server. So the first thing which will happen in a scenario like this will be discovery message broadcast. So the client is going to broadcast discovery message so that it can locate the DHCP server and it can get the IP from him. So we can simply see here in this scenario, we have this picture where a client is connected with server. The client is sending DHCP, client broadcast discover messages. Discover message is being sent to the server. Once the server receives that, the server is going to unicast offer message. So DHCP server unicast the offer message. It is going to offer some IP to the client that, okay, I can give you this IP. Do you want this? To which the client is going to respond with the request message. Client will say, yes, I need that IP. Can you give me the full details? Now this server is going to complete the process with the acknowledgement and will send the whole details like router address, subnet mask, or the DNS address. So that's how your DHCP works. And the next thing we have, like, this is a very simple protocol. You are just making the IP configuration from manual to dynamic. You are using some server or using some router to assign the IP address to the end devices like PC, laptop with the help of DHCP. Then the next protocol which we need to talk about is HTTP. Introduction to HTTP would be, the first thing is it stands for Hypertext Transfer Protocol, communication protocol between the client and server, and it works on the application layer for World Wide Web, which is www. So you must have observed while you open some web page on your browser, you get HTTP or HTTPS as the in the beginning of the URL, right? So that is the protocol which is being used to fetch the web page for your application of browser. Now this communication happens between, again, client and server. So client is the one that is using the browser. It is browser that requests for, receives and display the objects, and the server is the one which receives the request and respond to them. So in this scenario, we can simply say we have this laptop on one end, then we have this desktop on the other end, and there is this server. So this laptop, in order to look for the applications provided by the server, will send the HTTP request, and the HTTP response will be done by the server. Similarly, if there is a desktop also, then also this is going to be the same. So HTTP is the one which is basically acting behind your devices when you open your google.com or youtube.com. So I hope you guys got to learn out of this and you were able to understand this. Make sure you read more about them. I hope you guys enjoyed the video. I'll see you in some other video. Till then, take care.